Hello everyone, hope you're doing well. So today we are recording a session. I'm recording a session for the linked list. So we'll understand all the different scenario of the linked list. How does it work internally? Okay, when do we use it? What are the purpose of it? Okay, because it is one of the most important data structures, and you will get a number of questions during the interview regarding linked list. Okay, so let's start with it. So linked list is a linear data structures in a which elements called node. So whichever element we are adding on it, right, that is called node, are connected using the references. Okay, so elements will be having in the linked list that will be in the form of node. We'll understand what is a node. Okay, no worries. So first let's consider the definition only. So linked list is a linear data structures in which element called nodes are connected using the references. Reference is nothing like address only here. Then you can understand. Linked list is following doubly linked list internally. So the linked list, which actually in Java we have predefined class linked list. But in the previous data structure, that was C and C++, right, we have to create linked list manually. There was no predefined class there. So if you're creating that your own a linked list, like that time you can write your own logic, but here we have written the logic already written. We have to just use them directly. So what are that classes, what are the methods that we have, that we are going to utilize that in Java. So we don't have to create any manually linked list in Java, but we have to understand that how does it work internally actually, right? So linked list is the following doubly linked list in Java. So there is a two type of linked list, or I can say three type of linked list: singly linked list, doubly linked list, and circular linked list. So here it is following that concepts of doubly linked list internally. Okay, it is not contiguous memory allocation. So that means that node, I mean where the data will store here, right? They are not contiguous memory allocation, and it is not synchronized one. Linked list is not synchronized. That means it is not thread safe. So in multi-threaded environment, not recommended to use linked list. It allow null insertion, we can insert null value on it. It allow duplicate values, we can add duplicates on it. It is order preserve. So order preserve is same like as I told yesterday also, right? The order I will add the element, the same order I do get the element as well, retrieve the element as well. So these are the some properties of linked list. It is a linear data structures. Again, let me repeat it. It is stored data in the form of nodes, and that will called that connected by the reference only. Okay, how does it look and all? Let's understand with the diagram itself. Okay, so see here we have a linked list 2 diagram. Okay, one we have a like, so whatever you are saying here, like complete block which will having a and this empty, right, that is called node only. So linked list does store data in the form of node, and node will having a two information. Node will having a two information. First one is called data and second one is called address. So here next that we are saying, right, that is called like reference only. So here A, B, C, D, these are the 4 different values which are stored into a linked list. So these 4 values are present in a different node actually. So here I have a 4 different nodes, and every node having a different values like A, B, C and D. So in the A, I'm taking, suppose it is a first element. So I'm taking here first element means it is a head element. So first element always called like a head element only. And if it is connected to the B, it could connect with any of the node. So that will understand in which node it is connected. So here in the next part, right, it will having an address of it. Suppose it is connected with the B. So A is having a some address, B is having a some address, C is having a some address, D is having a some address. Every node having their own specific address. So that means if A connected with B, that means A next part is having address of this particular B node. If B is connected with the C, that means B is having an address of C node. If C is connected with the D, that means C is having an address of D. And if D is not connected with any node, right, that means it is the last element. That means D is not having any address, so it will having a values like null. So that's why we are putting the null here. So inside this block, what will be the last node always will having a null, and the first node from the till before the one last, right, they will having address into the next part. So linked list always store data in the form of node, and node is a combination of 2 things. One is the address and second one is the data. Okay, so this is a singly linked list which do we design, but Java does internally follow doubly linked list. This is structure Java does follow internally. So in doubly linked list, what happened, right, we have a 2 address part. In singly linked list we have a 1 address part, but in doubly linked list we have a 2 address part. One is called previous address and next one is called next address. Let's say A is a head element. So here we have to understand head element. Head element will be the first element. So head element, the previous address will be the null, and next will be the address of that coming node, whichever is coming node. So that means the coming node is like suppose B. So A is having an address of B, right? And B will having a 2 address here. So that means first it is having address of A and then it is having address of C. So in doubly linked list, right, every node will contain the 2 addresses. One will be the previous node address and second will be the coming node address, whichever is coming to the next on it. Okay, but if it is a head element, that means the previous node address will be the null, and if it is a last element, then the next part will be the that address will be the null. So in doubly linked list, we have to understand there is a 2 scenario. In the head, we have a previous address will be null, and in the last node we have a like next will be the null. So this is the structure of the doubly linked list. So by default, Java does follow doubly linked list internally. So Java does work. I will let you know how does it work and how does it look internally, the memory diagram and all. Memory diagram we are understanding in terms of class, how does it implement it and all, that we will understand it. But one thing you have to understand, that in Java we do not have to create our own linked list. Yeah, in interview purpose they may ask you, can you create the custom linked list? But in terms of practical, in terms of example perspective, right, we use in day-to-day activity in our projects, right, that time we do not create any our own linked list. We do use the predefined linked list. It is also part of util package. So yesterday I told, right, ArrayList is also part of util package. Same like linked list is also like a part of util package, right? So there is a difference between singly linked list and doubly linked list. Okay, now let's understand with some example. How does it look and how we can create object and how we can add some element on it, and what are the different method of linked list. Okay, now let's come to the IntelliJ IDEA directly. So here I created one example of linked list demo, and here I created one object of linked list. So here I used linked list, right? So you can see here it is directly coming from util package. So I am using here util.linkedList. Okay, so you don't have to create your own linked list. We are using predefined linked list, right? Now let's go to the implementation of it. How does it look actually? How does it look? So let me open this implementation of this class. So it is a linked list actually here. Okay, so this linked list class, it is a predefined class. You can see here it is a predefined class which is extending abstract sequential list, and it is implement list, dequeue, clonable and java.serializable. So here I can say that linked list having a 2 implementation. One is using the list and second using the dequeue. That means linked list can be part of the queue as well. So we have a 2 data structure, right? List and queue. So linked list can be part of queue and linked list can be part of list also. So it is implementing 3 interface: list, dequeue, clonable and serializable. One difference that you have to understand with ArrayList is implementing random access, but linked list is not implementing the random access. So that means for retrieving purpose, linked list is not better. I will tell you why. Because complexity is also one of the scenario. But here you can understand one more way. There is one interface who was giving the faster access of the element called random access, which is not implementing by the linked list. But ArrayList is implementing it. ArrayList is implementing it, right? So you can see here inside that we have a like node. So suppose there is a one linked list, and here I have a 2 node, one node and second node. So here it is talking about the first and it is talking about the last. So first means, that means we are talking about the previous, right? That is a pointer to first node, the point to the last node, right? So that means that will point to the last node and that will point to the first node. And here we have the size as well. So size will be 0 by default. Okay, I mean by default it will 0. So whenever we do add the element on it, and on the basis of that it will increase the size of it. So that is the internal implementation of linked list. That's why I'm saying it is working with the doubly linked list actually. It is using doubly linked list internally, where we have 2 different addresses. One is the first and second one is the last. Okay, now let's come to here. So this linked list will having a like 2 type of allocation. It is a homogeneous or heterogeneous. So this time the linked list which I created, that is a heterogeneous type. That means I can add element any type of it. Like for example, I'm storing a string. If I will remove this double quote, that time it could be float. No problem, it will store, right? If you want to store any other values also, we can store it. Like suppose here I'm storing this like 100 without double quote. So this time it will behave like an int, this will behave like a float, it will behave like a string, it is behave like a strings only, right? Now let me comment this sort part here. Okay, so whenever we are going to system.println linked list, and let me run this code. So when I will run this, right, you can see I'm getting here 100, 100.5 hello and null. So as I told yesterday also, right, in the previous recording also, when do we create the direct data structure, right? We do not create like this way. This way means which could accept heterogeneous element. We do give a specific type on it. So let me create, this will store the string type only. So here I'm creating our linked list that will store the string type only, right? So always when you will work on a real project, right, we do not create any data structure that could take all type of element. We do create only a specific type of element. Okay, very rare scenario we do use that which could accept different type of object, but normally we do create with a specific type of object only. So this time this linked list is accepting the string value only. So let me put that into a double quote. So that time it will be a in double quote only. So that means they are storing the list, okay, in the form of a string. So this time if I will display this element, right, that time it will give me all that element like 100, 100.5 hello and null, right? So the order which I'm adding the element, the same order I'm getting the element, right? It is allowing null values, right? It is not thread safe, okay, that we cannot see now, that we can use if you use this in a multi-thread environment, right? And one more property we have, right? It is order preserved, it is allowing null values, right? Yeah, these all are the properties of, let me show you what are the property. Yeah, non-contiguous memory allocation, that's fine. I told, right, and non-contiguous means it will store in the form of node and they are present in the different addresses, different location. So because of that, they are not contiguous memory allocation. Like array we have, right? In array, what do? It is a contiguous memory allocation. Like see here, it is continuously starting 0, 1, 2, 3, 4, 5. Right? So that means it is a one block where indexing is increasing automatically. But in linked list, it does not happen. In linked list, what happened, right? It is managing index like this way only. I am not sure that here A is connected with B, but A can connect with the C as well. A can connect with the D as well. So that all depend on the addresses only, addresses only, and it may be possibility where they are. I mean, they are not a same block, right? There is a one block, there is a two block, third block, right? So the block are in different locations. So that is also one of the use of linked list. So that's why it is called, it is non-contiguous memory allocation. Okay, now let's understand some methods of linked list. What are the methods? So first method we have used add method. So add method is from the linked list only, right? And here we are using all the strings, right? And one way we can create object of linked list using this as well. So that is a also again I can say preferable way, because linked list is a child of list only. So we can create the object of linked list equal to new linked list, but we can go with the list as well. List linked list equal to new linked list, right? So that is a more preferable way as compared to previous one, because we do always create reference like that way, where it will create the reference of the parent and object of the child. If you have not aware about that object-oriented programming, runtime polymorphism or overriding, please watch that. There you can get the more clarity about it. Okay, so we are adding here add method on it. So add is just adding the element on it, right? So what happened right here, it is simply display the element. And if you want to sort the element, right, that time we have a collections.sort method that will look later on. Okay, so collections is our utility class, right, where we have to perform the sort of linked list. So how will you sort this element? So we have some rule of sorting. Okay, you cannot sort all type of element. We have to follow some rules of it. What are the rule? Let me explain that as well here. So the rule of sorting is that all the elements should be the same type. The first rule of sorting. Okay. Second rule is that null values should not be there. If there is any null values, then sorting will not be work. It will give null pointer exception. Okay. And element should be comparable or comparator type. So what is a comparable comparator type? That also I will let you know. These are the two interfaces which will only use for sorting purpose. So what we are doing here, we are simply creating a one. We are using a sort method. So sort is taking a one linked list object which will simply sort the element. So here actually I'm using null. So here this null is not like a null values. It is going null as a string. So that time there will not be any issue. Let me run this. So it is giving some error for me. Okay, here I'm using some method of the linked list, right? That's why it is giving the same issue to me. So I can do one thing. Let me look it, create it linked list only. Sorry, object of linked list only. I will tell you why it was giving the error. So here I'm creating the object of linked list. Now let me run this now. So this time you can see that it is giving 100, 100.5 hello and null, right? But if I will go without double quote, that means it is treating like a null value only. So that also one way we have. Null we can go without double quote, or null we can go with double quote. If we'll go with double quote, right, that time it will not count null as a null. That means nothing. It will count as a value. But if we'll go without double quote, then only it will count as a empty or nothing. Right? So this time at beginning itself we will get the exception. Right? What does it say? That null pointer exception. Okay. So here first it will display the element, and then second it will give me collections.sort will give me a null pointer exception. So always remember that null insertion is not allowed into a linked list. Okay. Now let's understand with some method here, which is very useful and very important actually. Okay, so it is having n number of method that we are going to understand now. First method is a get method, right? What is a get method? Get method is used to retrieve the element. Remove is removing the element. Content is for searching the element. Index of, if you want to get to know index of any element, we can use index of. Get first element will give you the first element. Get last element will give you the last element. So these are some of the popular method that you will use in linked list in day-to-day implementation. So get will give you first what? It will ask some index. So whenever we do pass some index, it will give me the element of it. So here we are passing 0. What does it give? It will give me first element like 100 only. And here it is going to remove 1. That means it is going to remove index of first element. That means first index it is going to remove. So here 100 will having a 0 index, 100.5 having a 1 index, hello is having a 2 index, and null is having a like no index. I mean it will be having a like 3 index, 0, 1, 2, 3 index, third index, right? So that will remove first, then content it will check search 100 does it present or not, right? So it will return the boolean value only, true or false. You can see it will return the boolean value if it is present true, otherwise false, right? Index of hello. So hello is present at which index? 2 index. So here I will get the output what? Here I will get the output like 100. So 0th index we have an element like 100. So it will give me 100. What I will get here? So it will simply remove 100.5. 100.5 will remove from that. Okay, and content, what does it do? Does linked list having 100? Yeah. So it will give me a true here, right? What index of will give? Hello. So hello index is what? Hello index is 0, 1, 2. So it will give me like 2 index here, right? Get first element. Get first element, what does it give? It will give me a first element of it like 100 only. So here I will get 100 element, 100. Okay. And here what I will get last. So it will give me last element, which could be nothing like a null only. So here it will give me null. So that will be the output here, right? But one thing you have to remember, that sorting cannot be possible. I will make a separate video for performing sorting. What are the different rules and how can we do it? I'm not going to cover on it. Here I'm simply covering that concepts of linked list. How does it work internally? Okay, so for sorting I will make a different video. How does it sort elements like that? Clear it. So here we are adding the element and we are getting these. So these are the same like some of the method, very popular actually. And how does it perform the complexity, time complexity, and if you'll get some interview questions like comparison between linked list and ArrayList, which one is better in what scenario? Now let's understand that one actually. So in the complexity perspective, right? So you can see basic node structure, we have a data with next, right? And here we have a linked list, it will store data like that way. So last will having a null value here, right? And here this will having a like address of the previous, next coming node. So each node point to the next node. So this information is completely called the node only, right? Now let's understand the complexity perspective. So we have a different kind of operation. So insertion, here we can have a like multiple position at beginning, at end, at specified position. So three way we can perform insert operation in linked list, right? Delete operation we can perform also with many way, and search element and access by index. So let's understand. If you are inserting at beginning, then time complexity will be big O of 1. I told, right, complexity means what? Number of iteration, how many number of iteration it is taking. So when you are inserting at beginning, it will take only one iteration. So that means just update head pointer. Insert at end, right? That means it will take n number of iteration. That means must travel to find last node. So it will traverse to the last node. Insert at position, right? That time also it will take n number of iteration. That could be must traverse to the desired position. Wherever it is, right? It could be 4th position, 5th position. So it has to traverse to all the positions. Till that, it will not get the specific index where you want to add the element. Delete from the beginning. If you delete from the beginning, we have a like big O of 1. Only it will take one iteration. Delete from the end. Delete from that, it will take n number of iteration. Search element. For search also it is take n number of iteration. Must check each node sequentially, right? Access by the index, that also it will take big O of on n, and must traverse from the head to index, right? So this is the complexity here. Only two scenario we are getting, that O of 1, O of 1. That means the linked list is better only for these two scenarios, insert at beginning or delete from the beginning, right? Rest of the scenario that is coming in red, right? That means it is not preferable. We will look some other data structures who will take less number of iteration, so that will use that type of data structure for that particular purpose, right? So these are the two is the best scenario, insert at beginning and delete from the beginning. Now let's compare that with the linked list. So linked list and array list. Let's start insert at beginning. Linked list taking one iteration, where array list is taking n number of iteration. So who is a winner? That means linked list is a winner. Insert at the end. Linked list will take one iteration and array list will also take one iteration. Okay, that means both are taking the same. That means for insert at the end, both are used. So that is a tie. That's I've written here. Tie means both are the same. There will not any difference on it, right? Access by element. So for access by element, linked list taking n number of iteration, where array list is taking only one iteration. So that means which one is better here? Array list is better here. So whenever you are accessing the element, right, array list will be better because it will taking one iteration, and linked list is not better because it is taking a number of iteration, right? Search element. If you are searching the element, right, linked list and array list both are taking a number of iteration, right? Memory uses. Linked list does use more memory, where array list is take less memory. That's why winner is array list only, because linked list will always store data in the form of node, where it is having a two things, data and address part. But array list will not having address part. Address does manage automatically, right? Address is not going to store with any block, but in linked list it is going to store in a particular block. So that is a difference between array list and linked list. If someone will ask an interview, you can answer like that way. Which one is better in what scenario? Okay. Now let's having a one scenario here. I just make a, I am adding some node here. How does it work? Let's see one example. So add node. So it is going to add node. So it is having a two things. What? Data and address. So first node we have, right, that is a head element. So head element will having a 76 and that address is having a null. Now I want to add one more element, like suppose 21. So that means now the 21 will be the next element, 76 will be the head element, right? Now let's add 56. So that way that linked list does create internally, right? They are all in different locations. 76 will different location, 21 in different location, 56 will be in different location, right? I can add n number of node here that will be in different locations. Clear all, that means all the node will remove first. That means the first node, whichever it is there, right, that will remove. So if I click on the remove first, the first node will be created. Remove first, remove first. So it is going to remove into the descending order. Clear it. So that is an interactive demo where we can get to know, understand that how does this linked list work internally, right? So that is about kind of simple linked list data structures. Okay. So if you have any question, you can ping me over that chat. Okay. And thank you guys. Thanks for watching. Take care. Bye bye.